Hi and welcome to the first episode of 2022. I am Funny Chidella and you are listening to Kubernetes Notes. Let's first take a look at why Kubernetes came into existence. The traditional deployment era, which consisted of physical servers. The issue with that was there is no way to define boundaries with respect to resources used by applications on the physical servers. This caused resource allocation issues. So when we run multiple applications, there can be instances where one application would use up most of the resources. One solution is to run each application in its own physical server, but this would cause issues when we have to scale, and the resource utilization would also be very poor in this case. Also, physical servers cost money, and therefore these are not the valid solutions. Then came the virtualized deployment era, where we started using virtual machines. In this approach, we run multiple VMs on a physical server. This helps applications to be isolated from each other, and the security is also improved as the applications cannot freely access each other. Virtualization also helps in better resource utilization and scalability. While creating each VM, we can set the resources to be used by the VM. But this is not a perfect solution either. Each virtual machine is just like a physical system with its own set of OS and memory allocation. So we cannot keep adding virtual machines without causing a hit to the performance. And after the virtual machines era, we came into container deployment era, where we started using containers. Containers are similar to virtual machines, but they can share the operating system of the physical server. Each container can just have the application dependencies and run the application code. Containers are considered to be lightweight. Similar to virtual machines, containers have their own file system, CPU, memory, process space, and more. These are decoupled from the underlying infrastructure and can be ported across different clouds and OS distributions. Kubernetes, as we know, is a container orchestration software. So I will also give you the formal definition of a container, which is application-centric methods to deliver high-performing, scalable applications on any infrastructure of your choice. Containers are best suited to deliver microservices by providing portable and isolated virtual environments for applications to run without interference from other applications. Now that I've finished my checklist of sounding like a container salesman, let's go through the advantages of containers. Now, I won't be going through these advantages in detail. Containers provide the following advantages: agile application creation and deployment, continuous development, integration and deployment, dev and ops separation of concerns, observability, environmental consistency across development, testing and production, cloud and OS distribution portability, application-centric management, resource isolation, resource utilization, and they help create loosely coupled, distributed, elastic, and liberated microservices. The episode will continue after this short message. If you like our work and would like to support us, you can visit buymeacoffee.com/Chintu. That is buymeacoffee.com/CHINTU. Now, back to the episode. Now that we know what containers are and what they help us with, let's talk about container orchestration. These are tools which groups systems together to form clusters where containers deployment and management is automated at scale. Kubernetes is just one of the few available container orchestration tools in the market. Some of them include Amazon Elastic Container Service, the Azure Container Instances, Azure Service Fabric, Marathon, Nomad, Docker Swarm, and of course, Kubernetes. Now let's talk about the features of Kubernetes, starting with automatic bin packing. So you provide Kubernetes with a cluster of nodes that it can use to run containerized tasks. You tell Kubernetes how much CPU and RAM each container needs. Kubernetes can fit containers into the nodes and make the best use of your resources. The second feature is self-healing. This automatically replaces and reschedules containers from failed nodes. It kills and restarts containers unresponsive to health checks based on existing rules and policies. It also helps prevent traffic from being routed to unresponsive containers. Next is horizontal scaling. Applications are scaled manually or automatically based on CPU or custom metric utilization. Service discovery and load balancing is next. Here, containers receive their own IP addresses from Kubernetes, while it assigns a single DNS name to the set of containers to aid in load balancing requests across the containers of the set. Next is automated rollouts and rollbacks. This seamless rollout and rollback application updates and configuration changes will help you constantly monitor application health to prevent any downtime. Kubernetes also helps with secret and configuration management. You can manage secrets and configuration details for an application separately from the container image. This helps you avoid rebuild of the respective image. Secrets consist of confidential information passed to application without revealing the sensitive content to the stack configuration like on GitHub. Next is storage orchestration. Kubernetes allows you to automatically mount a storage system of your choice, such as local storages, public cloud providers, and more. And finally, there is batch execution. Kubernetes supports batch execution, long-running jobs, and replaces failed containers. So now that we know what the features of Kubernetes are, let's talk about Kubernetes architecture in the next episode, starting with the master node. Thank you very much for your time, and I'll see you in the next episode.
If you like this episode, please consider following us wherever you hear your podcasts.